Welcome back to our video series on exponential and logarithmic equations. This is part 3. In parts 1 and 2 we covered exponential equations, first basic ones and then messy ones. So in this video we're going to talk about logarithmic equations. So logarithmic equations are the ones that involve logs. They might look something like the log base 4 of 5x plus, we'll say 9 equals 3. This we can see pretty clearly is a logarithmic equation. It's got a log in it, it's got an equation. And we have to solve these by using the trick we know about logarithms to examine what they mean. Here's what a logarithm means. Ignore the equals 3 for a moment and just look at this. This means what exponent can I put on 4 to get 5x plus 9? That's what this means. Log base 4 of 5x plus 9 means what exponent can I put on 4 to get 5x plus 9? Or symbolically, 4 to what power is 5x plus 9? This is what the logarithm means. This is what it's always meant. From the first moment we introduced logarithms, this is what they meant. And the answer to this question is 3. 3 is the exponent you can put on top of 4 to get 5x plus 9. 4 cubed is 64. There you go. There's our linear equation. It's that easy. Subtract 9 from both sides. 55 equals 5x. X equals 11. That's all there is to it. You just gotta stare at the log for a minute, figure out what it means, and then reconstruct the equation using an exponent instead of the log, and you're basically done. You've got your linear equation pretty much right away. Generally speaking, this will always be the base. This will always be the exponent. And this will always be the result. 4 is the base, 3 is the exponent, 5x plus 9 is the result. So let's do another one of those. Maybe 2 or 3 more. And then we'll see what happens when these things get weird. Alright, let's talk about log base 2 of 3x minus 7 equals 6. Following the pattern, we're just going to transform this into an exponential. 2 is going to be the base, 6 is going to be the exponent, because this means what exponent do I put on top of 2 to get 3x minus 7? 6 is the exponent you put on top of 2 to get 3x minus 7. Bam. There's our linear equation. Step 1. So you just got to figure out what 2 to the 6th is. I almost said 32, but I don't think that's right. I think it's 64. Yeah. 64 equals 3x minus 7. So we'll add 7 to both sides. You get 71 equals 3x. Don't know what 71 thirds is. Probably 20 and something. 23? I don't know. Doesn't matter what it is, it's x, and I'm done already. Let's think about the log base 5, 10x plus 2 equals, I already did one that equals 3. Let's have this one equal 4. First step, we're going to transform this into a linear equation using the definition of a log. This means what exponent am I putting on top of 5 to get 10x plus 2? 4 is the exponent you put on top of 5 to get 10x plus 2. So 5 to the 4th is 625 equals 10x plus 2. So 623 is 10x. And 62.3 is x. That's it. That's all you got to do. There are some more exciting versions of these. Logarithms get interesting when there's other stuff going on. So, let me do a very basic other stuff is going on example. And we'll save the really exciting other stuff is going on examples for part 4 of this video. Let's say 2 log of 3x minus 1 equals, or no, more than that. 2 logs of 3x minus 1 plus 3 equals 7. This is what I want to do for the vaguely weird example. And the moral of this particular story is, the trick that we've been using to transform a log equation into a linear equation, that only works when the log piece is isolated. We can't do that here because this 3 is in the way, this 2 is in the way. First we have to clear out the 3 and the 2 so that just the log piece is isolated. Then we can do that trick to turn this into a linear equation. So I'm going to get rid of the 3 first. We'll subtract 3 from both sides. 2 logs of 3x minus 1 equals 4. Now we'll get rid of the 2 by dividing both sides by 2. The log of 3x minus 1 equals 2. Now we are in our familiar territory where we just have an isolated log equals a number, and we can use our trick to transform this into a linear equation that solves itself pretty nicely. If there's no number here, the default is log base 10. So this means 10 squared equals 3x minus 1. So 100 equals 3x minus 1. 101 equals 3x. And x equals 101 over 3. So, most of this is the same as what we've already done. Some added steps at the beginning. If you need to isolate this log, isolate the log. That's a good primer introduction to all the different basic forms of log and exponential functions you're going to encounter on the homework for this section. There are some slightly more exciting things we can do with logs. I'm going to save those for a different video because they get kind of weird. So, another video will be incoming shortly.